Hi, a very good evening to all. I hope your day is going well. So we are looking at into pharmaceutical data analytics, pharma data analytics, where we have encountered, where we have discussed a lot about it, right? A lot about it, the application of the analytics, application of the pharma analytics. There we discussed some 8, 9 applications of it. Some of the applications, maybe we can say like that. Application of pharma analytics. And once we cover the, once we ended with the application, then we entered into the part 2, which is crisp MLQ methodology. Crisp MLQ methodology. Where we have discussed a lot about the crisp MLQ methodology. I've discussed a lot in the crisp MLQ methodology. Then in that we know that there are some 6 phases in it. What is the phase 1? The phase 1 is business and data understanding. Business and data understanding. Phase 2 is phase 2 is what it is. Data pre-processing. Once we collect the data, we have to pre-process it. Data pre-processing. What is the phase 3? The phase 3 is model building. Where we build the model with supervised and unsupervised learnings. Supervised and supervised learnings. Then the 4th phase is model evaluation. Model evaluation. 4th phase is model evaluation. Then the 5th phase comes into the picture. In 4th phase, we know that we will evaluate the model. Yesterday, we discussed some evaluation technique for the categorical and the numerical data. All right. We will use confusion matrix for that. We have discussed all these things yesterday. Then we have model deployment. Model deployment. Deploying the model is very important. Model deployment is very, very important nowadays. Then monitoring and maintenance. Monitoring and maintenance. So these are the 6 phases which we encounter yesterday. And we discussed a lot with an example as well. And we have discussed about yesterday about the datas, right? I hope yesterday we are off our way through the datas, where we covered a lot of datas. We are about to explain about the cross-sectional data, and time series data. Cross-sectional data and time series data. I say that the cross-sectional data where date and time is unimportant. So date and time is unimportant. Since the name it is a time series data, the date and time is important. Date and time is important. When there is no importance to date and the time, then there is no importance in the order, that is sequence. When there is an important to the date and time, sequence is also being important, right? So this is about the cross-sectional data. You have to know about a little bit idea about it, right? While yesterday we covered discrete, continuous. You know that what is discrete and what is continuous. Continuous is a numerical data. Discrete is a categorical data. Numerical data can be in decimal format, whereas in categorical data cannot be in decimal format. That is discrete data. Discrete data, we have intervals. Sorry, discrete data, we have nominal and ordinal. Nominal data or categorical, that is binary and multi-class classifier we have. And ordinal data, we have orders and all these things come under ordinal data. We have encountered this. Count data is also called as a discrete data. Then interval and ratio data. Interval is subjective. A ratio is objective. It is based on objective. So the most preferred data is ratio because it performs all the statistical activities in the world. Second importance is interval data because interval data is also performing most of the statistical operations. We have discussed that. And then we encountered about like quantitative, qualitative data. Quantitative, which speaks about the amount of quantity amount, 5 kilometers. Qualitative, which speaks about the quality, that is how far, very far, like that. Then we have structured and unstructured data and semi-structured data. We have discussed it. And then big data we have encountered. Then we encountered cross-sectional data, time series data, and panel or longitudinal data. Cross-sectional data, time series data, date and time is important. And we have encountered panel data. Now, what is panel and longitudinal data? Panel and longitudinal data. What is panel and longitudinal data? So the combination of cross-sectional data and the time series data is also called as a panel or longitudinal data. That is the combination, which means cross-sectional data will have some multiple columns in it. Okay. So the important point about cross-sectional and time series, cross-sectional time series, cross-sectional data have multiple columns in it. Time series data, only single columns in it. Only single column will be there. So multiple columns in it and only single columns in it in the time series data. Fine. And also cross-sectional data, we know that date and time is unimportant. Date and time. Sequence is also unimportant. date and time is important in time series data and sequence is important. Now I say that this panel and longitudinal data. We are discussing about panel and longitudinal data. This panel and longitudinal data will have the properties of cross-sectional and time series data. What are the properties that it will have? That is a question now, right? So the property of cross-sectional data, that is multi-columns are allowed here, multiple column properties of cross-sectional, also date and time importance of the time series. Date and time is important. So multiple column, date and time is important. I hope it is clear. Multiple column, date and time is important. That is panel data. So, okay, fine. I hope it is clear now. Now balanced versus imbalanced data. Balanced versus imbalanced data. Now we want to speak about what is balanced data and what is imbalanced data. Balanced data. Imbalanced data. Imbalanced data is also called as rare events. We will speak about it. Now, when we have two class category, okay, when we have two classes, if any one of the class, so why two class when the output variable is two class, if any one of the class having less than 30%, if any one of the class is less than 30%, okay, then it is imbalanced data. So the data should be equal or it will be more than 30, both the classes. So if 100%, 30% should be above, should be the other class as well. So if any one is there, then it is an imbalanced data. When if it is less than 30, the number of data points less than 30%, it is a imbalanced data. When we speak about categorical data with more than two classes, then no thumb rule and all here, but we can say by the look itself, right? We can say by the look itself. Balanced or imbalanced, we can say. Then continuous data. Then continuous or numerical. So now we saw the categorical. In continuous, what will you say? By seeing the probability distribution. By seeing the probability distribution. Probability distribution, normal distribution or balanced. Normal distribution or balanced. So by seeing the probability distribution, I can say continuous or not. Right? If a data is normally distributed, then it is fine. This is not normal means it should be imbalanced data in it, right? So not normal, exponential can be a not normal, or left skewed can be, or right skewed can be a not normal. So some rare events can also be happen in the imbalanced data. Let's say rare events in the imbalanced data, we can say that credit card fraud, rare times only the fraud occurs. Resign from company or not, rarely few will resign. So that is called as also imbalanced data. So when we take on credit card fraud analysis, the frauds are very less, right? Like that, resignation will also be less. When incoming will be high, resignation will also be less. So this is about the balanced and imbalanced data. So we saw some categorical and numerical. So categorical data can be checked with, if it is less than 30, when it is two class. If it is less than 30, it is an imbalanced data. If it is more than 30, it is a balanced data, both any one of the class. If more than two class we have, then if we have more than two class, then we have more than two class, we can say that the data is imbalanced. So the data here, which is greater than 2 class, less than 2 class, greater than 2 class. So greater than 2 class means 3 class, 4 class maybe. So we can look at the data and we can say, when we have a continuous data, that is numerical data, then we can see the probability distribution and we need to answer it by seeing the probability distribution only. I hope it is clear now. Fine. So this is about the imbalanced and balanced data, right? Then this is about the data, guys. I hope the data is clear. Then we have to see the batch processing, or that is offline processing and online processing data. So offline, online data, we can say. Online processing or the live streaming data, it's very important data we have to process simultaneously. Live monitoring is required, so high costly machines are required for that. But batch processing, that offline data, like if you apply for a loan in a bank, the bank manager will sit, maybe it will take 1 or 2 days to approve a loan like that. So low configuration system is fine for batch processing, but high configuration system is required for online processing or streaming, right? That is streaming data. Okay. So I hope it is clear almost. And we have output, we will call that output as a Y, or also we can call this output variable as response dependent target label outcome. Input as input, predictors, independent, covariates, regressors, all these things we can call. Rows are called as records, observations, cases, entries, entities, samples, all these things. And columns are called as features, column variables, all these things. Then in the data, we have discussed about primary and secondary data, I think, in the last class. Not much detail, but we'll discuss something in detail now. So primary data, we have 3 types of data in this, right? Primary, secondary, syndicate. Syndicate data. Primary data, first thing. It is costly, yeah. It is costly. First point to be noted, primary data is a costly data. What it is costly? Why it is costly? Yeah, you are going to go to the roadside and you need to ask for the data to the clients, or you give some money to the people to collect, give the data to them, to us. So that is called as a primary data, which is costly, time consuming, is it some disadvantages we can say. The advantage is exact data you will get. Exact data you will get. Exact data you will get. Now, then syndicate data is also a kind of primary data where we will pay money to the company and we will get this data. If we want any data from a company, then we can pay them a money and we can get the data. We can pay them a money and we can get the data. That is syndicate data. Now we have secondary data. It is easy and quick. It is easy and quick access to data. We will get quick access to the data. It is less costly, not that much costly. It is very less costly. But some irrelevant informations will also be there. We have to do all the pre-processing. That is why what we are going to do now. Irrelevant data. So how it is easy and quick? Maybe it may be available in the internet already, or any externals, internal or externals. When we do a project for a company or a customer, then they will document then the document will be stored in a location, that is OPA, organizational process asset, it is called as. So OPA. So from the data, from there the data could be there. From there, if we collect the data, that is called as a secondary data. Okay, less costly. Sales record, industry records, ERP, CRM, open data source, etc. will come under that. So this is all about primary data, secondary data, and syndicate data. You have to know about. Fine. Fine. This is all about data, guys. So we have encountered all the data, I hope. What are the types of data? We started with continuous, then discrete, continuous, decimals accepted. Here decimal are not accepted. Meaningful 0 will be here and meaningful 0 will not be here in discrete. So yeah, that is why decimal is not accepted. Then we have in discrete, we have encountered the categorical and count. Categorical data is categorical and count. This categorical will have binary class, two class, binary class, multi-class category, binary class and multi-class. Count data is also a discrete data. Binary class, two classes, multi-class 10 to 10, 15 classes might be. And we have nominal, ordinal, interval, and ratio. Nominal and ordinal are somewhat okay. It's ordered. It is not useful. Interval data is subjective. And the last one is objective, that is ratio data, which is very, very preferred data. Fine. Then we discussed about quantitative and qualitative data. So there is something called CINROC. What it means, INROC. Continuous, discrete. So continuous data is interval data, ratio data, and count data. Discrete data is nominal, ordinal data. So we have to keep in our mind CD in ROC. Okay, CD in ROC. Continuous, discrete, continuous or interval, ratio, and count data, and discrete or nominal, ordinal data. See, we have to remember in this fashion. So I hope it is clear now. Then, so interval data, no meaningful zeros will be there. Ratio data, meaningful zeros will be there, right? Fine. So here, continuous data, where it is? Yeah, interval data, no meaningful zero. So it is 0, it is non-zero, like that. Okay. We have to remember in some ways. Then we have a structured, semi-structured, structured, semi-structured, and unstructured. Then we have big data. Then we have a cross-sectional, time series, panel or longitudinal data. Then we have balanced versus imbalanced data. Then we have offline, online. Then we have what it calls as primary, secondary, and syndicate data. So this is about the data, guys. You have to remember these kind of things. Now, there are some errors we can do while collecting the data. What are the errors? Random errors we will make. What is random errors? While collecting the data, random error is possible. Like there may be a measurement devices. Let us say if you are measuring the temperature, you will use thermometer for that, right? If you are measuring temperature, you will use thermometer for that. Thermometer might be a malfunction, so you will collect the wrong data. So for that, they will use gauge RNR device to check the measurement condition, measuring devices conditions, how it is. They measure the measuring device condition, how the condition of it is, like that. Okay. Now that is fine. That is random error. If we collect the data and if it is having that kind of error, that is random error. That is fine. Then we have systematic error. Systematic errors. So random errors, systematic errors. Let us say in US election, Trump said that Twitter said that Trump will lose based on the survey it made, but in real world he won. So there might be an error by the system as well. Then we have error of choosing what to measure. So we might choose a wrong thing to measure, right? If a person is having a good grade, it is not like that he is having some good IQs. Not only on his IQ, right? It may be on his good tutors, good study materials, its interest, and all these factors is also into it, right? We can't judge it just like that. So errors of choosing what to measure. Random error, systematic error, errors of choosing what to measure, errors of choosing what to measure. Fine. So I hope it is clear. Then errors of exclusion is there. That is fine. So that is fine. So random error, systematic error, and errors of choosing what to measure. So while selecting the data, bias and fairness should be avoided. Bias and variance. So Amazon's face recognition was trained on only white faces, not on the black faces. Only on white faces they trained it. On black faces, it is not recognizing very well. That is a drawback. Right, darkened skin faces were not being detected. So use of gender or race, etc. Maybe in a loan default prediction also, model need to be avoided, like the use of gender, race, that we cannot make into count. That is fairness on bias. So I hope that now the data is clean. Now we'll enter into the data cleaning and pre-processing all these things now. So today we are going to discuss about EDA and pre-processing steps, exploratory data analysis and pre-processing steps. What is exploratory data analysis? What is exploratory data analysis? To understand this exploratory data analysis, EDA, exploratory data analysis. Exploring the data by doing some analysis, right? Exploring the data by doing some analysis. That is what exploratory data analysis is, right? I hope it is clear. Exploring the data by doing some analysis. Fine. Before entering into that, we have to know about some probability techniques. Probability. Right. What is probability? Simple terms, probability is number of interested by event by total number of events. So number of interested event by total number of events. Number of total events. Number of interested events by number of total events. The probability value varies from 0 to 1. We know that. Probability varies from 0 to 1. Overall probability equal to 1. Okay. So the probability value varies from 0 to 1. The overall probability value is 1. Okay. Number of interested event by total number of events. Number of total events. Fine. Random variables. Now, what is variable? What is variable? You need to know about probability we done. We have to know about random variables. Random variables. When output of the variable vary, when output of the variable vary. Let us speak about, take a die. Like this. The die has some 6 phases. So the output is 1 to 6. Some output will be there. When output of the variable vary, right? The output is varying 1 to 6, it's varying, right? That is called as variable. Random. What is random? When each of the possible outcome have the chance or probability associated. See, this have a probability of 1 by 6. Number of interested event is 1 and total number of event is 6. Probability is 1 by 6. Everything is having a probability of 6. So when each of the possible outcome have the chance or probability associated, it is called as random. So each of the variable, if it is having a probability associated with, is called as a random variable. When both the properties have, it is called as a random variable, right? So I hope it is clear. Variable when outcome when output of the variable vary, right? That is variable. Random when each of the possible outcomes have the chance or probability associated, then it is called random. Okay. If each variable having a possibility of that is a probability associated with, then it is called random. Both properties combine to form a random variables. I hope it is clear now. Random variables, that is random variables, varies represent variable representing by using uppercase X. Random variable, uppercase X. Random variable, uppercase X. Okay, fine. Then probability distribution, you can know that the probability, the sum of the all probabilities equal to 1. We know that distribution of 1 along the 6 variable is called as a probability distribution. For this rolling of a die, which have 6 outcomes, so the distribution of 1 along this 6 variables, that is 1 to 6, is called as probability distribution. So 1 by 6 plus 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 1 by 6. So that is probability equal to 1. Now, if your random variable is discrete, what is discrete? Which doesn't have a decimal point, that is categorical data. Where there is that is categorical data. Then in that case, it is called as discrete probability distribution. So if your random variable, this is your random variable, always x-axis. So if your random variable have a probability distribution with a discrete value, that is called as a discrete probability distribution. If your random variable is continuous, that is numerical data, then it is called as continuous probability distribution. This is called as probability distribution. Probability distribution. Okay. X-axis is random variable, y-axis is probability distribution. I hope it is clear now. Now, before entering into the data cleaning process, you have to know this kind of things. So that is the reason I have taught you. I hope that you people understand about the inferential statistics. Right? We have discussed about probability and random variables, probability distribution. Now we are getting into the inferential statistics. Let us say, if you are going to analyze the battery life of the users of iPhone users battery life, you need to analyze. That is your business problem. What you'll do, you will go to the 10 billion people and you will ask you will go to the 10 billion people, all the 10 billion people, and you will ask the result. That is not going to work. So out of this sample, this population, this is the population. Out of this population, you come to know that 80% of the people, you come to know that around 80% of the people are using iPhones only on US. Only the 20% are using the iPhones on other countries. So what you'll do, you will take the survey only on the US. So business decision you are making, business decisions, because 80% is already in US. Only 20% is split up on among the other countries. So now you take this 80% only from US alone. So you'll now US alone. Now in this 80% people, you are doing simple random sampling. What it means, simple random sampling? You will randomly pick up the people without any bias, Yesterday we have discussed about what is bias and variance. Variance and bias. Yesterday we have discussed about bias and variance. Variance when the testing accuracy is high and training accuracy is less. Bias when the training accuracy is high and testing accuracy is less. So without any bias, I'm taking. Then I will do the sampling here. Then I will do the sampling. So here I will take some 10% of the people, might be. So do analysis on this people, on this 10% people, and give inferences for this population. I will give inferences for this population around this 100% of the people. So I'm just analyzing only 10 people or 10% of the people, and I'm giving inferences based on the population. I'm not on the sample. So that is called as inferential statistics. We have another inferential statistics, that is hypothesis testing. Hypothesis testing. Another inferential statistics, that is hypothesis testing, where we have parametric and non-parametric. We have parametric and non-parametric. Hypothesis testing, parametric and non-parametric. So this we have to somehow manage. This inferential statistics clear, I hope. Now let us enter into the session. Exploratory data analysis. We will look into EDA process. Data pre-processing in pharmaceutical analytics. What is exploratory data analysis? Exploratory data analysis refers to the critical process of performing initial investigations on data so as to discover patterns, to spot anomalies, to test hypotheses, and to check assumptions with the help of summary statistics and graphical representations. Okay, so exploratory data analysis refers to the critical process of performing initial investigations. So this is the first investigation on the data whatever you make. First investigation on the data, whatever you have make. First investigation of the data to spot anomalies, to test hypotheses, and to check assumptions with the help of summary statistics and graphical representations. So using some statistical and graphical representation, you will find out these errors, anomalies, and hypotheses like this, and you will rectify it. You need to rectify it. So this is what exploratory data analysis speaks about. Okay, clear. It is the first stage of investigation which is done using the statistical and graphical representations. That's it. EDA. EDA starts by asking some basic questions. What is the basic questions? We will discuss that. Of dataset to make an initial assessment of the data structures and quality to facilitate a plan of attack. Okay, fine. So EDA starts by asking some basic questions. Starts by asking some basic questions. Is there an existing unique record ID or fields populated with numbers dates or alphanumeric characters? So we have to check the data type of it. What is the distribution of numeric values? What is the distribution of numeric values? How many values exist for categorical fields? How many values exist for categorical fields? How many fields have been left blank? How many are multiple data sets related? So, how many are uniques? Is there numbers, dates, or alphanumeric? So what is the distribution of, whether the distribution is numerical or categorical? Then what type of distribution it is? Then how many values exist for categorical field? Is there any null values present in that? Or any missing value is there? So these are the analysis you will make. That is the first question you will raise on it. Done. EDA graphical representations. So we will encounter one by one. Let me explain my things now. So we are starting with exploratory data analysis. The first analysis we will take here is first moment of business decision. So for your business decision, what is the business decision we took based on the inferential statistics? We took that in US and UK, there is only 80% of population, 80% of people, there is 80% of people who are using iPhones. That is what the business decision I made. So first, now I made the business decision. I want to do the measures now. The first moment of business decision is also called as measure of central tendency. The measure of central tendency are mean, median, and mode. First moment of business decision. Mean, median, mode. So mean, median, and mode are the first moment of business decision. Mean. Okay, median and mode. I want to explain it clearly to you now. So now, let me tell 10, 20, 30,000. This is my A data point. A column, only one column, let us say, and I have these are my data points value. Now, if I want to take the mean, that is average. So what is the average? I will calculate 10 plus 20 plus 30 plus 1000 divided by 4. Total number of us 4. So 20, that is 60, 1060 by 4. And I divided by this is some 530, around 250 and 265. It will come. So 265 is my average value. Is it true? Because of this one value, my whole average is getting affected. The whole average is getting affected. Because of this only one value, my whole average is getting affected. So because of this one value, my whole average is getting affected. So this is called as an outlier. Outlier. I will tell you, I'll come to the points, okay? Outliers. So I can say that when I take an average for this kind of data sets, I don't know what kind of data set will be there, right? It can have an outlier, it cannot have an outlier. So when I have this kind of data, it is an outlier, which is an outlier. I can't use mean here. Wonderful. Over. Median. Median will do what? Middlemost value. It will take, median will take the middlemost value. So it will take, if there is a 4 values, that is 1, 2, 3, 4, it will take the middle value. Here middle value is not there. So it will take these two and it will take the average. And median will also do one thing. Before doing this, it will arrange in ascending order so that it will not get influenced by outlier. So median is not influenced by outliers. Median is not influenced by outliers. I hope it is clear now. Median is not influenced by outliers. Right. Median is not influenced by outliers. So we will use median. Fine. Mode. What is mode? Most repeated value. Most repeated value. Repeated value. Most repeated value. That is one mode. Most repeated value. So mean, median works only on numerical data. Numerical data. Mode only works on categorical data. Point to be noted. Categorical data. So mean only works on, mean median works on numerical data, mode works on categorical data. Mean represented using mu. Fine. This is about the first moment of business decision. Then the second moment comes into picture now. Mean, median, mode. First moment is mean, median, mode. Now second moment. It is also called as measure of dispersion. Measure of dispersion. Measure of dispersion, what it is? Fine. Now let us say dispersion is nothing but this is my average. This is my average sale of a company. On January month, the company phases an sales of this much, and February it is a loss of this much, and again on March it is having some high, and again on April it is low. Like this, it is having some thing. So here, the variance from the average to the point is called as a dispersion. Right? Fluctuations, dispersion, right? Is a variation. How much varying from the average to the point? That is dispersion. So here this much variance, here this much variance, here this much variance, here this much. So when I connect this, you can see that this is the variance. So measure of dispersion is variance. Variance. What is variance? Variance is represented using sigma. Okay. Sigma square. Okay. Sigma square equal to x minus mu the whole square divided by n. Standard deviation is root of variance. That is standard deviation. We have other one is range. So variance, standard deviation, and range. Range is maximum value minus minimum value. Minus minimum value. Maximum value minus minimum value. That is range. Maximum value minus minimum value. That is range. So I hope it is clear now. Variance, variance, standard deviation, and range. This comes under the measure of dispersion, that is second moment of business decision. So my question is, what is the probability associated with a single variable? Let us say there is a variable. Probability is associated with a single continuous value. I'm asking. Let's say 1. What is the probability? 1 by 1. So probability is 0, right? So number of interested event is 1. Total number of event is, sorry, continuous value, as I stated. Continuous means numerical. It represents in decimal points. So 85.0000000. So the probability associated with this interested event is 1. How much values it is? Infinite. Let's pick a question with the probability associated with the person with 85 kg weight. 85 kg weight probability. I want to know. So a person, the total number of interest in person 1 and 85 kg. It doesn't mention that 85.1 or 85.2. There are a lot of 85 kg, right? So probability of this person with 85 kg weight is on my infinity. That is equal to 0. Probability is a single value is 0. Probability that I'm going for a lunch exactly at 1 p.m. Is there any possibility that I can go at 1 p.m? My interested event is 1. Is there any possibility that I can go at exactly 1 p.m? No chance, right? So it is 0, right? So this speaks about the dispersion. Fine. I hope that first moment and second moment is clear. Let us jump into the univariate analysis now. Univariate analysis. Analysis on one variable to summarize the variable. So let's speak. There are multiple columns. If you take analysis for each and every column separately, we can do that kind of analysis using this kind of graphs: bar plot, histogram, and box plot. So I want to explain you about the bar plot. Bar plot is not much useful because it will be like this, the clumsy. You can't get much inferences from the bar plot. When you take the histogram, okay, the primary purpose of histogram is to give the provide the distribution, shape of distribution, skewness or not skewness, or left or right, or normally distributed or not. The secondary purpose of histogram is to find the outliers, identify outliers, find outliers. Box plot. Now, the primary purpose of box plot is to find the outliers. How it will be clearly visualize the outliers to us. This is the minimum value, this is the maximum value, and in between this, the values will be shown. So the primary purpose of box plot is to show the outliers. The secondary purpose is we can measure the skewness of this. So this is the two things you have to make in your mind. Histogram. Okay. We have a histogram is also called as frequency distribution, and frequency and probability. So let me say When y-axis, both have the random variables only, random variables, both have the random variables only. This is frequency. This is frequency. Here, density or probability distribution. Here, histogram or frequency distribution. That's the name. Only this is if changes, that is called as frequency distribution, that is called as probability distribution. But everything is same, right? Histogram creates a set of bins, guys. So this is one bin, that is group we can call. This is one bin, this is one bin, this is one bin, this is one bin, this is one bin. So histogram creates a bin. Histogram creates a bin. Right? I hope it is clear. Okay. Now, this is univariate analysis. Now we can jump into the third moment of business decision and fourth moment of business decision. What is this third moment and fourth moment? Third moment of business decision speaks about the skewness. Third moment of business decision speaks about the skewness. Skewness. Third moment, skewness. So it is also called as skewness. Let us say if it is towards right and like this, it is called as left skewed. If my distribution is like this, it is called as right skewed. And if it is like this, it is a normal skew. Normal. This is about the skewness. You can see. When the value is less than, when the value, if expected, that is E value, that is the second moment. Okay, the value is less than 0, 0. It is called as left skewed. That is called, wait 1 minute, let me tell you again. So if greater than 0, let us say greater than 0, values are greater than 0, which means 1, 2, 3, 4, 5, all these positive values are called positive skewness, negative values are called as negative skewness. Okay, now question is, while negative skewed, which will come first, mean, median or mode? Mean. Perfect. Positive skewness, mode will come first. Fine. So mode is greater, median is less than mean, right? That is the, so in negative skewness, mean will be here, median will be here, mode will be here. So mode is having some high, median is second, and mean is third. In right skewed, same, mode will be there, median will be there, and mean will be there. Same here, mean will be greater, median will be greater than mode because it is right side. Then fourth moment is also called as kurtosis. The inferences we can get from this is very, very tough. Kurtosis is the measure of peakedness, we can say. Peakedness, if it is on thin, we call this what? Thin peak, long tail. Thin peak and long tail. Let us say very long tail and the peak is like this. Long tail. It is called as positive kurtosis. If the peak is thick and short tail, it is called as thick wide peak and short tail, it is called as negative kurtosis. Thin peak, thick peak, short tail, long tail. Clear? Fine. I hope that it is clear now. Okay. For skewness, 0 is reference and kurtosis, 3 is the reference value we'll take. Fine. I hope it is clear now about the third moment and fourth moment. So we covered first moment, second moment, and third moment, and fourth moment. We discussed about box plot and histogram. right? It is, I hope it is clear right now. So now we will jump into the bivariate analysis. We have scatter plot, then we have multivariate analysis, pair plot, heat maps, and all these things are there. That so I hope it is clear now. First moment, second moment, third moment, and fourth moment we completed. Now, what are the pre-processing steps? Typecasting. Typecasting is nothing but the data types will check whether it is a float, integer, boolean, or string, or it is whatever complex. We will check the types. Handling duplicates. If there is any duplicate values, how to handle it? Handling duplicates. Handling duplicates. How to handle the duplicate values. Then outlier analysis. We will do box plot. We say our box plot, histograms, and all these things. How will we treat it? Using vensorization. All these techniques we will use. Vensorization is there. 3 retin testing is there. We can do that. Then zero or non-zero variances. Zero or non-zero variances are there. Variance. If any column is having zero variance, then neglect it. Since 1, 1, 1, 1, 1, 1, it is not going to give any detail about it, right? Waste. So we can delete this kind of columns. And discretization is also called as grouping. That is binning. Histogram we done a binning. Missing values. When we have some missing values or null values or any other values, then what we will do, we'll do some imputation on it. We will put imputation. Then dummy variable creation. Dummy variable creation. We'll create some dummy variables using label encoder. We have a lot of encoders are there. We'll use that to do the imputation. Then transformation we will do. When we will do transformation, when we want to convert a categorical data into a numerical data, we can do that. Or when we want to do unstructured data into a structured format, then we do some transformations. Then standardization is also possible. Standardizing the data, scaling the data, all these things. Then string manipulation is also possible in Python. Okay, this is all about when we have structured data. When we have a text pre-processing, textual data like text mining, text analytics involves automatically extracting semantic information from archives of biomedical text like Medline, abstracts, medical records, patents using linguistic, statistical, and machine learning techniques. For this, we use various tools like BERT, SPACY, and NLTK. After the extraction, the data needs to be processed. Various pre-processing is there, like tokenization is there, normalization is there, noise removal is there. So these are the few text mining processes we will look into. So what are the variables we have to remove? Remove HTML tags, remove extra white spaces, convert accented characters to ASCII characters, expand contractions, remove special characters, lowercase all text, convert number words to numeric forms, remove numbers, remove stop words, lemmatization. All this comes under pre-processing steps. Remove HTML tags, remove white spaces, convert accent character to ASCII character, then expand contractions, remove special characters. We have to remove all these special characters, special symbols, whatever we have in that, we have to just remove it. Then univariate, multivariate analysis we have discussed. So attribute information, okay, company, country, university, date, year, course, SF score ratio, rank, fees. So univariate analysis. Are there any extreme observation present in SF ratio? Multivariate null does the scatter plot of P and state and handle non-numerical data, whereas create a dummy variable for each category in countries. Then normalization. Scaling the data is needed for making data point generalized. Then transformation techniques, remove the skewness. We can use the various transformation techniques such as log transformations, square roots, and cube root transformations. So all this comes under the analysis. So with this, we end the session. Now we will see some codes. We'll take an example and we will discuss about it. Now, what did I do? I have imported NumPy, pandas, and I imported OS required. Then all these things I have done. Then I am taking libraries such as Cbon, SNS, Cbon as SNS, matplotlib.pyplot as PLT. These are the things that I taken. Then data characteristics, age, sex, gender, blood pressure, cholesterol. So the data which we have is age, sex, blood pressure, cholesterol, all these other days, and we have to decide the drug with the drug, and we have to predict the drugs. So I'm importing the data and I'm going to predict it. So now I'm checking whether is there any null values in my data and getting the sum. So there is no null values in my data. There is no null values in my data. So, okay, that I can see that, yes, there is no null values in my data. Now I'm getting the info of my data and describing it. The info and describes will give me the min, max, and all other values. So here I can see that maximum of it are integer, maximum are object, only 1 or 2 are integer and float. So what I will do, I can do the typecasting here. Typecasting here. Typecasting here. Then I'm doing some I can show some count plot here. Count plot is done. How much the drag Y and drag X is there. So this is good. Then we have sex count based on it. Then we have all these things. Sex count like this. Then graph, age, distinct, and all these things. BP count, blood pressure count. I'm taking the count of it. Simple. Count code is SNS. From Cbon count plot, you are plotting it. On what? On the drug based on the blood pressure. You are asking the blood pressure count it will give. Then you are taking the graph. Okay. So distinct plot, then I'm plotting the distinct plot. Then all these plots I'm doing for each and everything. So I'm just looking at the data of it. Swarm plot. Now the bar plot came. Okay, SNS dot bar plot. Bar plot will not give that much inferences. So this is done for each and every column. Then what I'm doing here is swarm plot. I don't want. I want to find is if any null values, I can do the sklearn impute. From sklearn dot impute, I have to impute simple imputer. Okay, then I'm creating a function def impute values and dt. So for each element of I and j in the values comma imp, impute equal to simple imputer, missing values is I, strategy is constant, and field is equal to j. Now imp dot in this from this fit drug dta and np dot new access. Okay, then all this analysis I'm doing it and I'm doing the imputation. Done the imputation, then label encoding. For label encoding, as I stated, sklearn.preprocessing, import label encoder, def encoder, features, le label encoder, drag feature, le.fit transform. Drags, infos, then all these things. Box plot. I say that in box plot, we can see the outliers here. Here you can see the outliers present in the data. What data that we have? The data is on drug TTA, where we can see the outliers here. Then how to remove the outliers? Here I'm using some user-defined function. I'm using the user-defined function here. You can either use an user-defined function or you can use any other things. So what I'm doing here is I'm taking the min, max, quantile, median, mean, all these values I'm taking it. Okay. Then I'm checking there is no outliers in my data. Now you can see no. Then scaling is done. Scaling. Then I'm splitting my data into the models. So model building is not required for us. So we will stop here. So in 360-digit mind map, this is the 360-digit mind map we have. This is 360-digit mind map where I go for the certification program in data science. When I go into this program, here you can see all the models, all the steps pre-processed, that 6 phases of CRISP-MLQ have been clearly explained here. Here we are doing some data cleaning process. So I'm getting into it. So data cleaning, data preparation. Here data cleaning process have all these inferences. So let me show you 1 minute. This is data cleaning. Typecasting. What is typecasting? Converting one data type to another. That is called as typecasting. You can see the examples as well here. Integer to float and array to series or data frames. Then duplicates. How to handle the duplicates? Getting single source of truth from various entries is one such example. The codes also is given here. Data.duplicated or data.drop duplicated will drop the duplicates. Outlier analysis. We have 3R technique: rectify, retain, and remove. Removal of outliers, retain, and rectify the outliers. Then masking, then swamping, then vincerization, trimming, all these things we have. Then zero and non-zero variances. We'll check whether the variance. Usually we ignore the columns with the same entries throughout, or if majority of the entries are same. All the entries of the columns can country show the same name as yours. Missing values. If there is any missing values, no values, then we will put the imputation, variant imputation and techniques. So we can see that the missing values can be used MCR, MAR or MNR. Then destruction method can be used. All single imputation can be used. Mean imputation, median imputation, mode imputation, random imputation, hot take imputation, regulation imputation, and KNN imputation. All these kind of imputations can be done with the codes also will be given from sklearn.impute. Just now we saw with an example, import a simple imputer. Like that we can do. Then model-based method is also there. What is model-based method? You just click into it and you can see that maximum likelihood and multiple imputation. All these things you can see there. Then discretization is grouping, as I stated, converting continuous data to discrete data. So what is continuous data? That is having a decimal point into it. Can have a decimal point or cannot have a decimal point, that it can have it. So converting that kind of data into a discrete data, categorical data, using it. Then dummy variable creations, one hot encoding, label encoding, dummy coding scheme, effect coding scheme, bin counting, future hashing scheme, and all these things. Transformation can also be done. Transformation we have check for normal distribution, log transformation, exponential, square root transformation, reciprocal, box Cox, Johnson. All these transformations are there. Standardization or normalization, it will make the data scale free and unitless. String manipulation, tokenization, stemming, lemmatization. These are the techniques. String manipulation, stop word removal, document stemming. All these things are given in our mind map where you can go and check. There are some blogs which are related to this. You can click the link and you can get the blogs as well. So this is for the day about the EDA and data pre-processing, exploratory data analysis of first moment, second moment, what is measure of central tendency, mean, median, and mode. It is given examples. Second moment, measure of dispersion, and it's given variance, standard deviation, range. Third moment is called as skewness, where it's given negative skewness, positive skewness, and all these things are given. So you can look at all these kind of things. Then we have feature engineering, right? I hope it is clear now. So this is for the day where we have discussed a lot about the exploratory data analysis process. So yeah. So we support you. You support us by subscribing to our YouTube channel 360DigiTMG. Please press the bell icon as well to get the quick notifications. We are the one which is providing 75 plus domains. No other in India is providing that. So make use of this opportunity for you. Then also, if you are a beginner, you can go to the TAM the Python video by Bharani Kumar Depero, who is our CEO, who is having a 17 years of less of experience. The person is tremendous. He explains the concepts just like that. You can have a better understanding from him. So I suggest you to go and watch his videos and support us to support you. Thank you. Have a great day.